Welcome to the distance learning packet. Here we have week 4, pages 6, 7, and 8. It all deals with applications of the parabola. Here we're going to go over the solutions. Waterworks, okay? How does understanding a quadratic equation help us create the fountain show? All right. Number 1. Jamie claims that each water fountain creates a jet water stream that resembles a parabola. Then Colin claims the individual jets can be represented by using this equation. Which student is correct in regards to their mathematical justification? Well, both of these are, they're all parabolas, but please understand that parabolas can be in two ways. They can be like this, which opens up forward, where it's ax squared plus bx plus c, or if you multiply this by a negative number, okay, it will look something like negative ax squared plus bx plus c. Oh, sorry, it's going to be, right, if you, okay, you see the negative here? Right, it's going to be this, like that. This are both parabolas, right? This is when it's negative. This is when a is less than 0. Okay, so who is right? I would say Colin is incorrect because his equation has the a value being positive. Okay, being positive, and as a result, the parabola is going to open up like a smiley face. Okay, I would say that the water fountain is an upside down parabola. You could say that. Okay. In other words, that is when the a value is negative. Okay, there you go. That would be correct. Okay, so Jamie is correct in that context. All right. Number 2, the height and horizontal distance in feet of a jet water stream can be controlled by changing the water pulse. Here's the equation. Consider each equation in the table that represents a potential change in the jet water. Determine if each equation compares to the equation cost the maximum height or the horizontal distance the water travels to increase, decrease, or not the change. Okay, so let's just graph this on Desmos and we'll see what happens, okay? All right, so I will pull up Desmos. All right, we have y equals to negative x second power plus 10x. All right, it should look like that, and we're just going to bring this over to Word, okay? All right, so this is how the y equals to negative x squared plus 10x looks like if you graph it on Desmos. And here you're going to explain how the equation impacts either the maximum height, horizontal distance, or both. All I'm going to do is I'm going to now graph these and we're going to compare. So this is how it's going to look like in Desmos. Here you go. I just typed in all the 4 equations. The top one is the original, and the bottom ones are the different ones. All right. I'm just going to bring this graph over, and now we're going to just type. All right. So I just brought it over here. Now we can just analyze it. So the first one was in blue. And so explain how that impacted. Well, it got smaller in size. So the original was in red, and so it got smaller, so basically shrunk. So the maximum height shrunk, the horizontal distance decreased, So you can write that if you would like. So this was in blue, right? So I'm going to make that blue. I could say the maximum height decreased, and the justification just looking at the equation, and the maximum height decreased, and also the horizontal distance decreased. So both decreased. Then the next one was in green, and that one you would say what changed for that one? Well, that one, the maximum height increased, and then the horizontal distance increased as well. Okay, the purple one is when it was flipped. This one it flipped, so no size change, right? Because look, same height, same distance. It just got reflected. Okay, you see, it reflected right. If you reflect it over the y-axis, so what the big conclusion is that you should realize that if you change the maximum height, the horizontal, if you change the maximum height, the horizontal distance will also change as well. Okay, did I write height correctly? No, it's EI. Yep. So there you go. You can't change the vice versa. You can't change one without the other. All right. Let's see. 3. Consider jet water produced by the fountain here. Blah blah blah. The jet function 1 shows the graph. The jet from fountain 2 not shown should be bounded by the jet from fountain 1. The difference is the maximum height of the jet is 8 and 12 feet. Write an equation in the form that can be modeled from the jet from fountain 2 to meet this criteria. Yeah, okay, so just pull up decimals, right? So that's weird, but we're just gonna play with it. Let's have decimals up. Okay, negative x squared plus something here, and this is gonna be b. Okay, this is the best part here. You hit add sliders, and you're gonna just change the value of b, right? So let's do, and we want here, we want so that the height of the jet is between 8 and 12 feet. Okay, so right now the height is super small, so we're going to increase it. Okay, anything yet? Nope. So let's increase it a little bit more, up to, let's say, 5. Oops, this equals to 5. Anything? Nope. Okay, let's increase it to, let's say, 8. Let's see what happens. Whoa, it got way too big. Let's go to 7. From 8, nope. Let's go to 6. Yeah, so look, 6 looks like it works. Let's say 4. No. 5. No. 6. Yeah, 6 is from 8 to 12. Let's go 7. Nope, so it should be 6. Yeah, so it should be y equals to negative x squared plus 6x. That would make that correct. And is that it? Yeah, that's it. That's all the equations. So there you go. Those are all your solutions.